Mathematics, Analysis and Approaches, Paper 2, Timezone 1, HL, November 2025. This is question number 5 of 5 marks. He has given us a table of class interval and the corresponding frequencies. And then he wants us to calculate the mean and the standard deviation of the data. He also says that the data can be approximated at a normal distribution. So by using that, I now need to calculate the interquartile range. I know that the interquartile range is nothing but Q3 minus Q1. So I'm going to use normal distribution to find out Q3 and Q1 and then subtract them. I'm going to quickly calculate the mid values of the class interval. As you know, the mid values of the class interval is nothing but the upper limit of the class interval plus the lower limit of the class interval divided by 2. So in this case, it's going to be 20 plus 15 divided by 2, which is 35 by 2. And 35 by 2 is nothing but 17.5. On Casio, I'm going to go to spreadsheet, and under spreadsheet, I'm going to try and enter all this data. Once I'm done with that, I'm going to go to calculate, and I'm going to choose one variable statistics. Again, we need to click on set over here because the data is only till A5. So I'm going to go back to set and change the cell references. So you can see that when I was trying to do the calculations, again, I had a problem. So I had to go back to set and calculate the one variable statistics again, where I had to make sure that the frequency was selected appropriately. Again, just make sure that you're, thorough with such calculations, okay? Otherwise, you may go wrong. I'm going to quickly do that on TI now. Let's say this is X, and that's the corresponding frequencies. Menu, statistics, start calculations, one variable statistics. And now I will choose X over here, corresponding frequencies, click on OK. And that should give you the mean of 27.5. And then you have the standard deviation of 6.279. Okay, now let's get to the next part of the question. The next part of the question says that this can be approximated to normal distribution. Let's quickly look at normal distribution. What we know about normal distribution is that the curve will have the mean over here. This is going to be my mean, and this is one standard deviation away. And this is one standard deviation away below the mean. Is about the mean, and then we have the two standard deviations away, and then the two standard deviations away below the mean. Now, when I'm looking for quartiles, I'm looking at 25% of the data. Okay, this is quartile 1. All right, and quartile 3 is basically 75% of the data. So if I look at this normal distribution from quartile perspective, I would have quartile 3 somewhere around here and quartile 1 somewhere around here. This is 25% of the data. The entire data till this point is going to be 75%, which means the remaining part is going to be 25% of the data. In terms of area, this is going to be 0.25 and this is going to be 0.25. Obviously, this complete area is going to be 0.5. Click on OK, and then you get 23.28. This is quartile 1. That's your quartile 3. All you now need to do is to subtract them. So let's go back to TI and choose that minus that and 8.445. So the value or the answer for interquartile range is 8.4, which is correct to two significant figures. Let's quickly look at Casio. On Casio, we're going to go to the option of statistics. Under statistics, we will choose distributions, and under distribution, we're going to choose for normal, and then we go for inverse normal. The data is going to be variable. It's not the list, and it's going to be a left tail test because we are looking for the area below the quartile 1. So here we can enter the area. So that's 0.25, and the standard deviation. That should be it. We'll click on execute, and we get the inverse normal of 23.27, which is the same value I get for in TI also. So if I want to, I can go back and change the area and say 0.75 over here, and that should give me the quartile 3, which is 31.72. That's how you calculate interquartile range for this data. That's it for this video. Thank you.